Hello, Algebra 1. Today we're going to look at our second day of solving equations and inequalities. So the first day was basically one-step equations and inequalities, but it was pretty long notes because we had to learn how to graph them on a number line. So today we're still going to be graphing them on a number line, but we're going to have multiple steps. So let's dive right in. Solve and graph each of the following. So we've got an equation here. And the reason I say they're two-step equations is because to get x by itself, we're going to have to undo two things. We're going to have to undo this 5. We're going to have to undo this minus 13. So what a lot of teachers say is they'll say that when we solve, we will do kind of the reverse of order of operations. So normally with order of operations, you would multiply first, then subtract. But since we're solving, we're doing inverse operations, we're undoing things. It's often wise to go ahead and add the 13 first, which leaves us with a 5x on one side of 15 on the other, and then we're ready to undo multiplying by 5 by dividing by 5, do the property of division, do it on both sides, and we get x is equal to 3, two-step equations. And then we'll graph this one just to make sure we recall how to do that. 3 in the middle, 4 to the right of it, 2 to the left of it, and a dot for equations when things are equal. And we don't need to shade anything because 3 is our only solution. Now, I'm going to be honest with you. You could start by dividing that 5 first, but you would have to distribute your division to everything. And a lot of students at this point in their math careers aren't good at remembering to do that. So I'm going to suggest that you take care of the addition and subtraction first. All right, for our second example, we're going to do this in 2 steps. You could do it in more, but we'll stick with 2. We're going to undo this 5, and we're going to undo this negative and dividing by 2 at the same time, all right? So watch how this is done. Do you guys see how this 5 is being separated from this negative x over 2? If it helps you to see it more clearly, you could add a negative like so. Add the opposite is the same thing as subtracting, just to see that this is a 5 that we need to undo. We're going to undo that 5 by subtracting 5. And that'll leave us with a negative x over 2 is greater than or equal to a negative 11. From there, I'm going to multiply by one thing to undo the negative and undo the 2. And I'm going to multiply by a negative 2 to get that done. Now, I just multiplied both sides of an inequality by a negative. So what did we learn the other day that we need to do? Well, we need to flip this sign around because suddenly everything on the number line is going to be, flipped around. And so the inequality symbol will be flipped as well. So we'll change that to less than or equal to. We'll have a 22 here. The negative times the negative makes a positive. The 2's divide out to make 1. 1 times x is x. And we have solved it. From there, we definitely need to graph inequalities. So we'll go 22, to the right's 23, to the left's 21. A circle or a dot. Well, it's going to be a dot this time because we can be 22. We can be 22, but we can also be anything less than it. And there we have it. I forget, I kind of like to box in my answers as well. Okay, so hopefully we're off to a good start. It's making sense. Pretty straightforward on the next one. I'm going to undo the addition and subtraction first. So I'll add the 12 over. I'm not going to show any work. I'm going to be sneaky. Add the 12 over and get 36. And then I'm going to divide by 4 and get 9. I'm being a little sneaky there, not showing a whole lot of work, but I don't feel like I had to. Yeah, I think you guys would be good with graphing that dot on a number line. Let's move on. All right, so on this one, we got to be careful. And the reason we got to be careful is A fraction bar acts as a grouping symbol. And what that means is that x minus 6 is grouped together and the 4 is on the outside of it. So on this one, it wouldn't be reasonable, it wouldn't be accurate to get rid of this minus 6 first, because it's basically trapped in this fraction. So on this one, we are going to start out by multiplying by 4. Because what that does is that undoes that division by 4. They'll divide out and make 1. And 1 times x minus 6 is just x minus 6. So by doing that, we've basically unlocked the x minus 6. X minus 6 is less than 12. And we're ready to add the 6 over and get x is less than 18. And we're ready to graph that. Circle or a dot. Circle, because we can't be 18, but we can be anything less than it. Okay, so notice the difference between a problem like C and a problem like D. On C, there was no fraction. We went ahead and got rid of the addition and subtraction first, then divided. On D, we had a fraction that we were dealing with. And because that x minus 6 was being divided by 4, we got rid of the division by 4 first. And then that opened things up to make it pretty straightforward to solve. There are going to be some problems later on that you're going to realize that you can distribute the division and do some things like that, but we're not there yet. So let's continue. Sometimes with equations and inequalities, you'll need to, or it's a good idea to, before you do inverse operations and start undoing things, you just simplify things that are easily simplified. And that's what we're going to do here, is we're going to simplify this 9x minus 6x. Those are like terms. So we'll combine those to make a 3x. And now we're back to a two-step equation. Subtract the 15 over, divide by 3, and we're there. On the next one, similarly, so it turns out the order that you add things does not matter. It has, I believe that's the commutative property. But anyway, the order that you add things doesn't matter. And what I mean by that is the 12 and the 3x we could swap around and then just add the 12 and the 4 together. So we'll combine like terms. And then we've got a two-step equation again. I guess I'll show every little step here. Oh, 52 minus 16. I should have that in my head right away, but I don't have my key in front of me. I'll grab a calculator. I don't want to make a mistake here. That makes sense. It's 36. Divide by 3, and we get 12. And just a heads up, since we haven't graphed any negative numbers, let me go back to E for a second. Let's graph that, just because I know number lines can be tricky, I should say, when you have negative numbers. So if you're at -9, to the right of that would be -8. You have to, as you go to the right, you got to get back to 0, so it's going to be -8. And then as you go to the left, you're going to get more negative, so -10. So I just wanted to do that real quick, just to have another bit of practice with graphing negative numbers on a number line. All right, so class, we really should have a word problem on here, but there's not one. So we'll just call it a day.